with StarWind Software. And today we're going to be talking about shared storage, specifically iSCSI software, and its use with VMware, vSphere, VMware Essentials, and Essentials Plus. You know, the types of packages that a lot of us are looking at to get into sort of that entry-level, high availability, vMotion type of scenario, and that license that a lot of us are going to be drawn to based on some of the budget constraints that we might have, but we want to make sure we're able to go ahead and unlock the shared storage component of that so we can take advantage of some of those features. Just a quick overview of sort of what the agenda is going to look like today, and for those of you that have heard me speak in the past, you know, sort of I do sort of a 50-50 split between PowerPoints and actual live demo, and I'll leave some time for live Q&A at the end. On the Q&A side, you know, go ahead and type your questions directly into the GoToWebinar interface for questions. I am going to get to as many as I can. If for some reason I don't answer your question, as long as you've typed it in there, somebody will follow up with you from our organization and make sure we get you an answer to that question regardless. There's also a chance that, quite frankly, if I don't answer it, I might not know the answer and need to research it. So, you know, but you will, by typing the question in there, you will get an answer from someone here at StarWind, whether it be myself or one of the members of the technical support team here. So just to go through the agenda real quick, we're going to start off with an overview of SAN technology. You know, I'm going to bring you through sort of the traditional fiber channel versus iSCSI. We're going to talk a little bit about SAN versus direct attached storage. And I know a lot of you are interested in SAN based on the fact that it's going to unlock some of the features that you're looking at in terms of being able to load balance virtual machines and provide yourself with some level of high availability. However, you know, there are some other benefits to SAN or the SAN approach, or separating the hypervisor from its storage or the application layer from the storage layer. We're going to talk a little bit about, you know, using software to build out a SAN, you know, using iSCSI and iSCSI-based software. We're also going to get into, you know, sort of why iSCSI is the right protocol. And then we'll dive into the technology aspect of this around iSCSI and ESX for the SMB, sort of how it all fits together from a shared storage hypervisor type of scenario. I've got a couple of overview diagrams that I can show you sort of what this looks like in the wild so that it doesn't have to remain in the abstract. And then we're going to actually go into the storage aspect of this, where I'm actually going to do a live demo of StarWind, show you StarWind functioning with an ESX environment, you know, and sort of how all that sort of ties in. And then we'll stop for some Q&A. So with that said, let me go ahead and jump right in. Now, you know, a lot of us, when we think about shared storage and we think about sort of what the options are out there, you know, we immediately look at or think about, you know, sort of the traditional fiber channel SAN, which is, you know, quite frankly, really solid technology. You know, it's a technology that, you know, has been around for a long time. You know, and you know, if you've been in this business for any length of time, you've either used one or known someone that's used this type of technology. The problem is, for a lot of us, is that it's certainly just outside of the range of what we can afford to pay. So when we start talking about, and the dollars add up fast, when you start talking about host bus adapters, fiber channel host bus adapters, in each one of the servers at the application layer, whether that be an ESX host, SQL Server, Exchange host. And then we start talking about redundancy. So now we're talking about multiples. You know, so we're going from, you know, maybe a $150 NIC card all the way up to now a $700, $800 HBA times 2 for each box that we want to include. Then we're talking about fiber channel switching fabric. And so, again, a lot of proprietary hardware here. You know, unless you've implemented one of these in the past, there's a pretty good chance that you don't have this stuff sort of sitting around the shop. Everything down to the cabling is going to be proprietary. Then we move down to the actual SAN itself and, you know, the array itself. And you know, again, we're talking about very, very expensive, you know, the initial cost, and then you start talking about sort of the ongoing maintenance of that and the total cost of ownership that's associated with that. So, you know, unfortunately, it prices a lot of us right out of the market when it comes to shared storage. Then we transition to the iSCSI SAN, and this is really where we start talking about a scenario where you're getting into shared storage, but you're leveraging commodity hardware. So we're not talking about anything proprietary here. there's a pretty good chance, now I'm not saying you would do it to put it in production, but there's a pretty good chance that you could find the equipment needed to put something like this together in your shop today. Any of us that have got sort of a spare equipment closet or something along those lines. And that's the beauty of this, is that you can go out and buy new commodity hardware to serve as your iSCSI SAN and keep that within the budget. And as you're going to hear a little bit later in the presentation, by taking the software approach, you really start to be able to get down to the granular level in terms of managing the expenses associated with putting something like this together. Now, a couple of things warrant, talking about here. We are talking about dedicated networking. So the nice part about this is instead of using proprietary fabrics like the fiber channel switching technology, we're talking about standard off-the-shelf gigabit switch, gigabit NICs. Preferably ones that are going to support jumbo frames. However, we're talking about something that's very, very basic and not very difficult to acquire and put into your environment. And then down below, when we start talking about the storage itself, again, we're talking about standard x86 architecture. So we're not talking about any sort of proprietary hardware. We're talking about something that you're going to buy from your hardware vendor, so you can maintain a level of continuity there. If you're a Dell shop, if you're an HP shop, if you're a Supermicro shop, excuse me, you're going to be able to go ahead and do all these things so that, you're going to be able to build out the hardware that's going to be able to meet your needs. So, an assessment around what you need for performance and what you have for budget, you're then going to be able to work with the hardware vendor that you choose to select the appropriate drives, to select the appropriate number of NICs, the amount of memory, CPU. So all of these things really are levers that you can pull on to not only balance performance with the budgetary constraints that we're faced with, but the bottom line is that it's going to get you into a shared storage model where you're going to be able to go ahead and move forward with your server consolidation on your virtualization platform and not be at the mercy of local storage, so not be without vMotion and high availability in the VMware Essentials package that or the VMware Essentials Plus package that you're going to go out and purchase. So again, very, very straightforward from that perspective in terms of looking at what your options are out there. Now, I mentioned in the agenda slide that we'd be talking a little bit about, the central storage model versus direct attached storage. I think that, again, a lot of us are here because, we're trying to solve a very specific problem. We've got, a server consolidation going on. We want to move to a virtualized platform. However, we want to have some of those load balancing and high availability options to us, and we need shared storage to do it. However, I think you'll find that once you go down the path of SAN and start building out that sort of central storage model, it's going to really sort of expand into the organization because of the ancillary benefits that go along with it. When we start talking about central management of those storage resources, so no longer are you trying to manage pools of storage in all of these different servers. You're basically in a scenario at this point where you've got all your storage in one spot and you can parse it out as needed to the application. So you get a much more efficient use of storage. So no longer do you have, or are you sizing servers and saying, well, I think based on the next 2 years of growth, I'm going to need 2 terabytes of disk, and I can't really afford the downtime, so I'm going to go ahead and put it all in now, and basically have a bunch of storage hanging around that's basically chewing up power and not doing anything. And so with that sort of central management piece with iSCSI, you're going to be able to parse that storage out as it's needed. The other piece is around data level protection. So, we start getting into block level snapshotting of volumes and the ability to go ahead and create highly available storage that goes beyond the RAID controller, and then ultimately doing things like asynchronous replication to get data over to a DR site. This all sort of plays into the other benefits that you get from a central storage model or from a shared storage model. Then obviously, we're talking about unlocking application features, in this case VMware, when we're talking about things like creating a vCenter or a vSphere cluster, HA cluster, and being able to use things like vMotion to go ahead and load balance. And then if you get into some of the higher licensing models, things like DRS and fault tolerance, all sort of part of the scenario when we start talking about shared storage in a vSphere environment. Now, the other piece here that I wanted to mention, assuming that you've bought into my argument that shared storage is the right model for you and that iSCSI is the way to go, the next thing I want to talk to you about is the software-based approach. Now, we talked a little bit earlier about budgets and, how, obviously you're working with one. Unfortunately, if money was no object, we'd all be doing something different. So, I think the bottom line here is that, we're going to allow you, by using a software-based approach to iSCSI, we're really going to allow you to customize the solution. So you're going to just make the decisions with some help from your vendor, like StarWind, around what type of hardware you need. And specifically, though, we're talking about that balancing act between the need for performance and the budget that you have available. So a lot of that goes into the speed of the drives and the number of NICs that you make available for iSCSI traffic, the amount of RAM that goes into the box. One of the nice things about the StarWind solution is the whole idea of being able to cache. So rather than buy extremely expensive disks, one of the options you have is to use memory, which is going to be cheaper than those faster disks, and basically front-end those targets with a RAM cache to make them even faster. But again, the flexibility that you're provided with in terms of leveraging some of the, the faster processors, the additional memory, the additional NICs, you're also creating a solution that can grow with you without having to do a complete rip and replace. So, you're going to be able to buy the storage you need, add storage as you go. So again, a real compelling scenario there when we start talking about the software-based piece. And then around iSCSI itself, iSCSI as a protocol, I think I touched on a lot of this earlier, but, we're talking about a scenario where, you're going to be able to leverage a lot of the non-proprietary or commodity standards that are out there, along with that commodity hardware backbone. So it's equipment that you've been managing your entire career. So we're not talking about learning something new. We're not talking about bringing in a consultant to handle these things. We're talking about something that's very, very simple and easy to set up. Resting on top of a Windows platform, which is another platform that we're all familiar with. So, again, this is something that it really makes a compelling case when you start looking at what some of your other options are that are out there, whether they be, a fiber channel solution or on the other side a NAS-based solution. We're talking about, block level, storage that really is going to be easy to set up, easy to use, and get you into this thing in a pretty tight time frame. So I always leave this slide in here because I'm, with these you never know sort of what the audience is going to look like. And so for those of you that aren't really that familiar with what iSCSI is, and of course, again, if you're attending something like this for the first time, why would you? Really what we're talking about is traditional SCSI disk commands that are going to be encapsulated in a TCP/IP packet, transmitted over a network via an initiator, where they'll ultimately hit the target server, be unpacked, and then ultimately written down to the disk subsystem. So if you think about the traditional disk, in this case here, the disk is usually running, or the I/O commands are usually connected to the board or the bus via, say a SATA cable or something like this. In this case here, we're just putting a little bit more distance in between the two and using a different protocol. So, again, it's going down that path of shared storage. It's going down that path of sort of centrally managed and allowing you to pool storage, as a separate entity within your environment. The iSCSI service runs on a typical Windows-based. It doesn't have to be anything, special. We prefer you run it on a server-grade OS, so whether it be 2003 or 2008, 32 and 64-bit compatible, not a problem at all. And, again, running on commodity hardware. So we're talking about traditional IP networks and off-the-shelf server equipment. So we're not talking about anything that is particularly difficult or hard to understand. Now, again, talking about some of the benefits of iSCSI, we touched on some of these earlier. But when you start looking at implementing a SAN and you start looking at a shared storage model from a project perspective, it can look fairly, or at least sound fairly daunting. But I think the nice part about iSCSI, and again, this is sort of vendor independent. The nice part about iSCSI as a platform is that it's really as close to plug and play as you can get. I mean, it's really that simple. Granted, there's going to be some best practices you're going to want to follow. There are going to be some things that you're going to want to do to make sure you optimize the networking pieces around this. You're going to want to make sure you balance performance expectations with the actual hardware that you put in place. But there's a lot of flexibility that iSCSI affords you in terms of what type of machines you're going to build this on top of. The fact that you're managing this through a Windows platform. The idea that you've got the ability to pick and choose what speed and density of disk you're going to wind up using. If you have a larger budget and performance is a problem, you go with faster spindles, or you go with solid state. If you're somebody whose budget maybe is a little tighter, but you still need that performance, you can't really compromise, well, then you can go with the slower drives, but load the box up with memory and front end it with cache, and for the price of an uninterruptible power supply and some additional memory, which is going to be a lot cheaper than some of the faster disk options out there, you can still put together a SAN that's going to allow you to go ahead and meet those performance requirements on a budget. When we talk about sort of some of these things, and really start to get into the cost associated and the overhead associated with managing proprietary hardware, not all of us have the skill set or the understanding of setting up a fiber channel SAN array, so we're going to go out and hire a consultant. But then, every time something goes wrong, or there's an issue, or there's a blip on the radar, we're bringing somebody back in. So, I think that, getting something set up to the point where you're going to be able to manage this on your own, because it's all of the parts are items that you're already familiar with. So maybe the idea of SAN is something that's new to you, but with iSCSI, the components are going to be something that you're going to be very familiar with. The other thing I like to mention here is, if you're somebody that maybe your company's already implemented a fiber channel SAN, this is something that's going to work well in a mixed environment as well. So if you started, a storage tiering strategy, or if you've got a lot of data on that fiber channel SAN that maybe doesn't need to be there, you could start the process of moving data off of that onto another platform, so as to not have to go out and expand that more expensive platform. So again, another option there for you in terms of how you go about setting something like this up. Now, one of the things that always does come up is performance. And so, it's important to understand sort of where the moving parts are when it comes to performance. And this is going to be particularly noticeable as you go through the process of consolidating physical boxes onto a virtual platform like vSphere. You go down that path of making sure that you're using a shared storage model to go ahead and make sure you've got high availability and you've got some failover capabilities around HA. However, your end users are going to expect the same level of performance, and you want to be able to deliver that to them. And so some of these things are going to be, the best practices around getting, that level of performance. It doesn't necessarily mean that you, when you're testing something like this, or you may be using it in the lab, that all this has to take place. But from a production perspective, the network isolation piece is going to be key. So, you're going to want to go ahead and on your ESX boxes have a couple of NICs that are dedicated to iSCSI. You're going to want to set up VM kernel ports on the V switches on those and actually assign those physical adapters. Gigabit at a minimum, scaling up to 10 gig E. And you're going to want to make sure that you've got either a dedicated switch or you've got something robust enough where you can go ahead and reserve some bandwidth via VLANs. Network optimization, things like enabling jumbo frames, something as simple as that. And this has got to be end-to-end. So on the ESX side of the house, you want to enable jumbo frames, and there are some instructions on how to do that. If you've got some questions on that, you certainly can ask us. We're certainly happy to help you there. You want to make sure you enable that on the switch that you're using for the storage, and then on the NICs that are going to be in your StarWind box. And again, this is going to make sure that network operates with a level of efficiency so that you're getting, for every packet that goes across the wire, you're packing more data into it. And so that's the importance in terms of the scaling of that standard TCP/IP network. The optimization of the TCP/IP window size, if you're using 2008 as your storage platform here, you don't have to worry about it. It's actually self-optimized. If you're using 2003, we'll have you do some of that. Again, you'll see a small margin. Again, it's about sort of optimization more than anything else. Matching disk speeds with I/O loads. Again, I think that one of the things that we want to make sure we do here is as you create your virtual targets to serve as the backbone of your iSCSI or of your data stores, your VMFS data stores, you want to make sure that the configuration of the RAID set happens properly. You can't get, you don't want to be in a situation where you've got, a misconfigured RAID set, or you've got a RAID 5 set, and you've got to understand the performance sort of limitations around RAID 5. And when you make those choices, again, everything is a cost. So, RAID 10 is going to give you better performance with higher overhead. RAID 5 is going to give you some protection. You'll make some compromises around performance, but you want to make sure that it's configured correctly. The proper use of or the type of disk. So, SAS versus SATA, drive performance here is going to be key. We're going to be able to a degree, help you sort of blur the lines here a little bit with the introduction of caching. So you're going to be able to use RAM as a cache, and I'll show you how that's done during the demo portion. But again, it's a decision you want to make when you're building out your storage boxes around what you can afford. And there's two main paths to go down. You can go with super fast disk and some caching, you get great performance. You can go down with the slower disks, use some caching to sort of bolster that performance a little bit. Again, all depending on your budget. And then matching RAID sets with I/O patterns. I think that this is one of those things that's often overlooked. To create contention at the disk subsystem level by having a scenario where you've got a random I/O workload competing for I/O or competing for time on the array with a more sequential workload. And so that ultimately will cause the level of disk contention and could potentially be a performance bottleneck. The other thing we talk about is monitoring. So do things like monitoring with something as simple as perfmon, looking at average disk queue lengths of your volumes on the sandboxes to make sure they don't climb above a certain point. And if they do, then you've got some sort of bottleneck there. And there are a bunch of different things you can do on the ESX side to sort of lighten that load as well. So, storage vMotion things around, or, set priorities with 4.1. Now you're able to assign disk shares to various VMs. So again, you're going to be in a situation where you can control that and make sure that even under contention, the right VMs are getting the I/O that they need. Okay, so the next is the data protection stuff. And again, I like to think about data protection on two levels here when we talk about storage. We're talking about availability, and then we're also talking about true protection, which is more related to the actual data itself. So the high availability stuff is making sure that you don't have a single point of failure from the storage angle, which we're going to talk about a little bit during the live demo, and setting up highly available storage. Doing things like snapshotting data volume. So, creating a volume, a snapshot-enabled volume, and presenting that directly to a VM, and creating snapshots of your data to create rollback points. Doing things like asynchronous replication for DR. That's another, key aspect here, or could be a key aspect of your strategy. If you've got a scenario where you're, in some place where you've got an awful lot of natural disasters, or you just need to have a contingency plan, that DR piece is key. And then using things like CHAP authentication, IPsec, LUN masking to prevent people from getting access to the storage at the initiator level. So, I want to go ahead and mask out so that not any guy with a Microsoft iSCSI initiator can connect to the storage that I'm using to run enterprise-level virtual machines. Now, the next slide here, this is really where we start to get into some of the meat of today and really sort of getting an idea of what the big picture looks like. So, when I talk to folks about this stuff, it's always easy to talk about the individual components, but I've created this rather rudimentary.
Welcome to GoToWebinar, Web Events Made Easy.
Now, obviously, over on this side, you've got your storage layer here, and I'm representing a couple of StarWind nodes in an HA setup. So basically, what I've got here is an active storage array that I'm presenting to the ESX cluster. Now, in this case here, If we talk about VMware Essentials Plus, we're talking about, a 3-machine license, 2 CPUs per box, where you're running virtual machines, in that HA cluster. So you've created that HA cluster, so you've got some level of high availability here, where, if this node goes down, it will spawn these virtual machines. It's running virtual machines on one of the other 2 nodes. Again, a scenario where you're needing shared storage in order to do that. But, it also begs the question, what good is HA at this level here if I don't have it at the storage level, if I'm creating a single point of failure? So, I think that, it's a scenario where, that's why I always present the StarWind high availability option when I do these webinars, because, you're going through the process of creating these things in you're not creating them in a vacuum. You're not putting them in a standalone environment. So you're getting the shared storage to be able to create that high availability situation, because, virtualization obviously puts us all in a situation where if one of these boxes goes down, it's not just one application that's impacted. It's 4, 5, 6, 10 applications potentially that are impacted. So we want to make sure we've got that available to us. Now, a couple of components that I mentioned during the presentation that I want to point out here. First and foremost, when you present StarWind in an active scenario, you have to have a sync channel here. And this is generally done when you're building out your storage through a crossover cable. So if these are going to be local nodes or adjacent racks, you simply want to plug a crossover cable up here. What this does essentially is when a scenario or data is written from the ESX iSCSI side of things, even with multiple paths available to it, each block is only going to be written down a single path, and each path is going to point at one of these 2 boxes. So if a data block is written down to node 1, it has to travel over the sync channel and synchronize here with node 2 in as close to real time as we can get it, to make sure that you have an always in sync high availability set. And we're doing some things here with this around getting commits from both sides before we commit back to the initiator to make sure you're never out of sync. So, but this is an important piece here, this synchronization channel, and it's really the lifeblood of your HA set. Generally speaking, what we recommend folks do is actually team NIC ports and plug them up via crossover cable to accomplish that. Now, the rest of this is pretty straightforward. I mean, we're talking about, the red networking being specifically for storage, the green networking being, what you're going to connect your virtual machine networks or vSwitches up to give the end user community access to the VMs. The orange network is a private network that maybe you're going to use for vMotion, and so you want to have some dedicated networking around that. So again, pretty straightforward stuff, but it's important to sort of stop and understand what this looks like before you go ahead and try and deploy it. Now, the next slide, I'm actually giving you a little bit of a blow-up here around what the iSCSI high availability looks like. And so, again, we're talking about an initiator with multiple connections going to multiple iSCSI nodes presented in an active situation, so that, data, and then obviously the path selection policy is set at the VMware level. So, whether we use a fixed path with failover only, or if we do take a round-robin approach where we're going to load balance data across these 2. The existence of that StarWind synchronization channel, because that path selection policy is something we can't control, that's ultimately going to be controlled by you, the administrator, that synchronization channel allows us to make sure that we can support any path selection policy you may put in place. Because data is only written on one side, we've got an avenue over which we can go ahead and make sure it's replicated. And so you've always got a highly available storage scenario. So that's kind of the blow-up of what that looks like. It's pretty straightforward, but again, and this is a very simplistic model, but it's important to show some of the moving parts here, I think, in terms of helping you get a visual around how this works. Now, with that said, let me transition a little bit over to an actual demo, in which case I'm going to actually start off with the StarWind side of the house. Now, on the StarWind side, there's a couple of different components. Now, I talked a little bit about, sort of what that looks like. So basically, you've got 2 servers that you're using for storage. The beauty of StarWind is they don't have to be identical, if they're going to be in an HA set. However, it doesn't make any sense to have differing disks, right? So if you've got 15K SAS drives on one side 10K or 7.2K SATA drives on the other, you're always going to be bottlenecked by your slowest disk subsystem. So, but with that said, you can use separate disks or separate machines of different makes, models, processor types, different amounts of memory. They don't have to match up exactly, which gives you some additional flexibility there. Now, once you've sort of installed your OS, you've got StarWind installed, and you've configured the physical RAID sets. And so that's part of setting this up is you're going to actually configure those disks into RAID arrays and ultimately present those up to Windows. That's going to serve as the physical platform for your virtual storage scenario. Now, with that said, and I've sort of fast-forwarded here, and I've got that done here already. I've got a couple of StarWind boxes that I'm managing, and I'm actually going to create a highly available storage device. So in this case here, as you can see here, I've got these two StarWind boxes. I've already got a bunch of storage on these things. But I'm going to go ahead and click on Add a Target so I can go ahead and start the process of adding a new iSCSI target. Now, I'm going to give it a name. In this case, we'll call it Demo Set 1. Now, StarWind gives you a number of different options when it comes to creating the iSCSI targets. 99% of you are here because you want to create hard disk-based targets. However, you do have the option of creating iSCSI targets from optical drives or tape devices, or actually creating virtual tape devices if you're in a backup scenario. I'm going to leave hard disk selected and click Next. Now, we also give you some options in terms of the way you're going to present this disk. So there's really two main options here. There's the physical option, where it's going to allow you to go ahead and pick a RAID set and actually pass that through directly as an iSCSI target without any of the data protection features that are associated with that. That's an option, not something that we see often used, but it's certainly something that we do offer as an option for you under certain circumstances. You may choose to go that route. The other options are the virtual storage devices. The basic virtual device is a lot like a Microsoft virtual hard disk. It's something very, very similar to that. It's basically something where you're going to take and assign it to a physical storage asset in your box, which is going to be one of your RAID sets that you've configured. The other options here are the advanced virtual. So the advanced virtual is where we start getting into, and they work the exact same way as the basic virtual in that they're a reservation of disk. They're basically a virtual storage device that's being assigned to a physical storage platform. The only difference here is we give you the flexibility now to go ahead and start utilizing these things in the data protection schemes that I talked about earlier, whether it be asynchronous replication, point-in-time snapshotting, or creating a high availability device. In this case here, for the purposes of our demo, we're going to go ahead and select high availability device. Now, the first thing it's going to do is it's going to ask me for the partner server. So where is the second StarWind box? And we'll go ahead and plug that in, and it'll ask me for the username and password for the service. And it goes out and does a quick check to make sure that the StarWind service is there. And then it's telling me now it's going to create a target on the partner server as well. And so it's just going to add the word partner to the end here. And I'm going to leave that set at the default because it'll help me track these HA sets. So you'll have a main server or a main target, and then it's partner. Now, the next step here is probably the hardest to sort of wrap your head around when it comes to creating these. But this is really where I'm actually going to take and create the virtual storage device on each side of the HA set, so on each one of these StarWind boxes, and actually assign it to a physical storage platform in that box. And so here, it's as simple as this is the current server. So this is .202. I'm going to click on the file browser, and I'm going to select this volume. And I'm just going to call this SEP1 disk 1. And I'm going to do the same thing on the partner server. I'm going to hit the file browser, and again, I'm going to choose the actual physical volume that I want to store this on, disk 2. And then I'm going to go ahead and sign. And notice I click Create New, so it's going to create a new storage device on both sides. And then I can size it. I'm going to leave it set at 256 megs. Now, the next step in the process is actually selecting my synchronization channel. So this is really where I'm going to go through the process of deciding which NIC in this box do I want to use as the synchronization. And again, you'll have either teamed a couple of ports together and assigned them an IP address, or you'll have a dedicated link in the box and you'll have the IP address associated with that on both sides. But you want to go ahead and make sure that you select that dedicated channel for data synchronization. And then in this case here, I've got a couple of options. I can clear the disks, so that's going to go through and fill it all with zeros. I can synchronize the disks in one direction or the other. So let's say I'm recreating an HA set. One of the boxes completely blew up on me, and I was running off of one node. I can go ahead and recreate my HA set and just synchronize in the appropriate direction with a fresh machine or a blank virtual disk. Or I can go ahead and select Do Not Synchronize, which is what I'm going to do here because I don't want to go through the process of waiting for them to sync when I know they're blank already. And then I want to set the caching option. Now, again, you've got a couple of different options here, and this is really where we're going to allow you to set caching on a target-by-target scenario. So you're going to be able to really pinpoint or direct resources at those targets that need the most. And so this is a real powerful feature here because what we're doing is we're essentially helping or assisting in potentially what is the slowest part of this equation, which is your disk subsystem, by basically creating an I/O buffer out of RAM. And so basically that I/O, instead of waiting to be committed to the disk subsystem before it can be confirmed back to the initiator, we're going to use memory and almost let it act as a solid-state disk, and we'll flash the I/O down to the disk subsystem as fast as we can. Now, with this comes some responsibility, obviously. You're going to want to make sure you've got a battery backup here. So, what I tend to recommend to folks is a unit that's got some integrated power chute technology so that in the event that a power outage happens, it will shut your storage boxes down cleanly. If you just pull the plug on something like this and you've got a huge cache there, you're going to wind up with a wildly inconsistent data set because that data that's been committed back to the initiator never made it down to the physical disk. But, again, if you start looking at scenarios where, you're going to invest in memory and battery backups versus very, very expensive fast disk, this gives you another layer of flexibility. So we'll leave this set at the defaults, and we'll finish up creating this target. And finish. So what I've done here is essentially created a new iSCSI target that is now eligible to be utilized by my ESX environment. So I'm in a situation now where I've created that initial highly available target, and now I'm going to go over to ESX and I'm going to create a multi-path device. So for those of you that are unfamiliar, sort of setting up the stack for iSCSI in a vSphere environment, there's a couple of different things depending on the flavor. If you're using, and really the only real difference is if you're using ESXi, you don't have a firewall to worry about. If you're using full-blown ESX, you need to go ahead and come down to the security profile here, and you need to go ahead and open the port for the software iSCSI client. And then once you've done that, you'll come into your networking here, and you're going to create your VM kernel port and assign it to a virtual switch and assign that virtual switch to a set of physical NICs in the box. Now, one of the things that you can do that's very effective in terms of load balancing is, and this is a little bit more advanced, and this is something that we can take up on a one-on-one basis if you're interested, but if you have multiple NICs in a box you want to use for iSCSI, you want to create individual VM kernel ports and individual vSwitches and assign those NICs. And then that'll allow you a much higher granularity around setting the load balance policies and spreading the load out. Rather than using the traditional sort of NIC teaming in VMware, you want to create the multiple VM kernel ports and assign those physical NICs to the iSCSI stack. Again, and things like that and things like enabling jumbo frames are sort of level 2, level 3 types of scenarios that we can cover with you on a one-on-one basis. But as you can see here, I've got my VM kernel port. I've got multiple VM kernel ports here, but at a minimum you need one. And this is really going to serve as the conduit between the ESX host and the iSCSI shared storage. Ideally, you'd have this on a separate vSwitch with a separate physical NIC assigned to it. Obviously, this is my lab environment, so I'm not able to do that here. The next thing you want to do is come over to your storage adapters. and you're going to select the software iSCSI adapter here, and then click on Properties. Now, I've already enabled all this, but you're going to need to enable this specifically, and then once you've enabled it, you can come over to the Dynamic Discoveries tab and start the process of entering the IP addresses that you're going to connect to your shared storage hosts from. So in this case here, I've got 2 separate boxes in my HA set. But if I had multiple NICs in here, I could plug in, let's say I had 2 NICs per box that I wanted to use for iSCSI, I could simply go ahead and start plugging in multiple NICs and creating those multiple paths to the storage. Once you've done that, you click Close, and it would prompt you, if I had made any changes, to rescan my host bus adapter. So I can simply come up here and do a rescan, and it would go out and fetch the targets that are available here from that perspective. And what you'd see here is then a list of the various targets that it's got, and then if I click on paths, I can see all the different paths that I've got here. Now, the next thing I want to do is come here and add storage. So once I've got my targets and I know where my targets are, I simply go through the process then of starting of adding storage. And so from there, once I'm able to do that here, let me see if I can find one that, and it just may take a few seconds here to get the storage to load. What you're going to see here is I've actually already created a handful of boxes, or already set up a handful of storage repositories that we can take a look at here. And as you can see here, I've got a bunch of them here. Now, one of the servers is down, and so I did that on purpose because I want you to see what that looks like. Let me hit Manage Paths here. So I just go through and create my storage based on the targets that I've brought in. So if I click on the Add Storage button up here, it'll identify those targets that are available to me, and I'll simply format them as a VMFS data store. Once that's done, let me kill this here because I think this one might be a little faster. Once that's done, I can then come here and verify that I've got multiple paths to the storage. And what I should have is, in an HA set, I should have a path to box A and a path to box B. So I'm spreading the load out across 2 physical servers. And then ultimately, and obviously I had a problem here with my virtual center. So unfortunately, I'm not going to be able to show you that, in that it seems like our virtual center server has gone offline. So, but basically, you get the gist. We're basically talking about a multi-path device here where, we're going to have multiple paths to the storage in a scenario where, you're going to have some fault tolerance there. So, unfortunately, I'll try logging into Virtual Center one more time here to see if I can bring it back online. This is actually a lab environment, so we have multiple folks that are sort of screwing around with this stuff here. But let me see if I can bring it back online. Yeah, it doesn't look like it's gonna come back. So, but at any rate, you guys understand or see where I'm coming from here. We're talking about, that once you get to that point, once you've created your data store, you'll have then gone ahead and you'll have that multi-path storage device. Then you simply start creating your virtual machines and assigning them to that shared storage. They then become eligible for high availability. They then become eligible for vMotion, and you can move them amongst the hosts in your ESX environment. So again, very straightforward. Not something that's terribly difficult to deal with, from that perspective. Now, if you do have questions on this, feel free to let us know. We've got a group of experts here that are really that folks can sort of roll up their sleeves and make sure we help you get that configured. With that said, I think what I want to do is I wanted to take the last few minutes here, and if there are any questions that anyone might have, I'm certainly happy to sort of start answering them at this point. And we're right around the 45-minute mark, which is sort of what I had sort of laid out for the actual presentation piece of this. So if there are any questions at all, please feel free to go ahead and type them in directly, and we can take it from there. Let me take a quick look here. So there doesn't seem to be any questions. So either everyone's not paying attention, or I just did that good of a job. But seriously, guys, if there are questions, if something does come up, either within the time frame we've got allotted here, or if you have a question after we've ended the session, I've put up all the contact information here for you guys. Feel free to use it. Give us a call. Drop us an email. we're more than happy to sort of help out in any way that we can in terms of making sure we help you get set up, get things going from the perspective of, establishing your shared storage environment and then connecting it up to the ESX host. So again, I don't see any questions here. So with that said, I think I'll go ahead and wrap it up. I really want to thank you guys for coming out. We are planning on doing a series of these throughout the course of the next couple of months. So keep an eye on StarWind from that perspective. Keep an eye on sort of some of the innovations that we're coming out with around iSCSI. We'll generally plan one of these events. If you're also interested in something maybe a little bit more basic and seeing some more of the blocking and tackling, feel free to attend. We run a Getting Started webinar every Thursday as well, so you can find details around that out on our website. I really appreciate everyone's time today. I hope you all were able to sort of take something away from this, and we look forward to working with each one of you as you go through the process of getting set up, and we'll take it from there. Thank you.